Welcome back. We are at part two of our lead ID process for a 9 lead dual voltage Y motor. So we're on step five, and what we're going to do is we are going to rotate the process that we just did in step four 120 degrees. So let's just write that down. Rotate process 120 degrees. So this will make more sense after I draw the schematic and label it. Okay, so there's my 9 lead Y, and we had this labeled as C, this labeled as E, and this labeled as G, so that doesn't change. We also just finished labeling this as A and T4 as I. And so in step four, we applied 15 volts to G and E, or T8 and T9, and we were looking for the lowest voltage in T1 and T4, which we found was A and I. So now what we're going to do is rotate it. So we're going to take our applied voltage between G and E, we're going to move it, and we're going to rotate it 120 degrees to G and C. Now again, we could rotate it the other way and it wouldn't matter, but we have to pick something. So I'm going to apply 15 volts to C and 15 volts to G. And again, that's an AC voltage. And then I'm going to measure between the outside three coils. So let's draw those over here. And even though you already measured and labeled A and I, it's a good idea to include that in the mix when you measure the next round here. So again, A and I is a pair, B and D is across another winding, and F and H is across another winding. So I already did this process. I applied 15 volts to G and C, and I measured between A and I got 1.6 volts. And then I moved my voltmeter to B and D, and I got 0.9 volts. And then I moved my voltmeter again to F and H and got 2.3 volts. So hopefully you already know what letters you're going to label phase B here. So same idea, so we're rotating the process. So if this is the applied voltage across this way, then this is going to be the lowest voltage induced perpendicular, not the ones that are closest. You can also think of it as the winding that's furthest away from where you apply it. Okay, so now we know B and D, we have to pick something. I'm just going to say that this is B here and this is D here. Because again, I don't know if this is D or B or this is D or B, but I do know it's this winding. Okay, now by default, we know that this is F and H. So we can label this now to F and H. And again, same rules apply. I don't know if it's H or F or H, but I have to pick something. Now, if you want and you're feeling unsure, you can move the voltmeter to C and E here, the 15 volts. Sorry, not the voltmeter, the source. You can move the source and apply it to C and E, and then just take some measurements across. Now, if it happens that, let's say, the lowest measurement you got when you did that was B and D again, or A and I, or something that's not F and H, then I'd recommend starting this whole process right from the beginning. Ohm them all out. Make sure that the group of three is labeled as you think of what it should be, and all the other ones. You might find that maybe you made a mistake in step one, and actually A and I weren't a pair; it was A and H. So just you have to start from the beginning, and it does happen. Okay, assuming that everything is correct and you did everything right and everything makes sense, we're going to move on to step six. So now we have it roughly labeled, but it's still not perfect because again, we don't know T4 and T1, which letter is which or which lead is which. And again, same thing for T2 and T5 and T3 and T6. We have it penciled in, roughed in, but we don't know. C, E, and G are going to be our benchmark, so those are correct. Everything around it, we still have to do a polarity check. Okay, so let's do that process now. I'm going to push this up. We're going to draw our drawing again. We'll get really good at this. When you're doing this process on your own, you don't have to draw it as many times as I am here. It's just easier to learn and read by redrawing it over and over again. Okay, so we got C, E, and G. Those aren't going to change. But now we're going to check A and I's to see if it's I and A or A and I. So here's the first step is we're going to add a jumper. I'm going to write our instructions over here. Add jumper to T4 and T7. Okay, so this is T4 and this is T7. And we're just going to put a little wire and connect that. Now, I'm going to put our lettering here, even though I don't know if it's right or not. So in the case of this motor, I'm going to put a jumper from the wire I to wire C. Okay, next step is we're going to apply 15 volts to T1 and T4. So I'm going to move my source here, 15 volts AC, and apply it to A and I in this case. Then I'm going to get my voltmeters, and I'll put a little circle for V for voltmeter, and I'm going to read between A and E, and then I'm going to move it over on this side, and I'm going to read it between A and G. Now, let's just take a look at what's going on here. So I'm applying 15 volts here. It's going to induce a voltage into this one and to this. Well, it's going to induce a voltage into all of them, but the only ones that we're really worried about are the ones that we're measuring. Now what happens is if I have 15 volts here, I'm going to induce, let's say 15 volts here. It's not going to be quite 15 because these are the same winding. And I'm also going to induce, almost 15 volts in these other ones. But they're not going to be, again, it's going to be a little bit less. Now what's going to happen is if the polarity is correct, so if this is like a negative and this is positive and this is negative and then this would be positive, we can't get in here and actually measure here, so that's why we have to measure these T8 and T9 terminals in this case. Let's just kind of do some quick math here. So this would be 15 plus 15 give me 30. And then this would go the opposite direction, it would be minus 15, so we'll be back to 15, but it doesn't quite work out exactly like that because this will be a little bit less and this will be a little bit less. So what ends up happening if the polarity is right is we're going to get about 3 extra volts out of this because this is a little off center. So let's see. Measure the voltages. Let's just write down our procedure here. So measure T1 to T8 and T1 to T9. In this case. Now, if both voltages are about, how are we doing here? That's a both there. About 18 volts, then the polarity is correct. So if both voltages are about 18 volts, polarity correct, don't change the letters. So then this is A and this is I, and you're done. So let's just go over that process one more time here. So I'm putting 15 volts, I'm applying 15 volts across A and I, and then I'm measuring A to E in this case. So I'm measuring all 3 of these windings, and if the polarity is correct, these are going to add, these will subtract, but they won't subtract quite to the degree. So if we could measure in here, we'd get almost 30 volts, but then we minus that. But it doesn't quite minus 15, it minuses about 12, and that's why we get 18-ish. Or that's one theory, anyhow. And then we go to the other side and it'll be the same idea, just a mirror effect. So if both voltages are 18, the polarity is correct. And I do highly recommend measuring both sides here. Because, well, we'll get to that first of all, let's do if it's subtractive. So if both voltages are about 12 volts, and you can see the 3-volt difference again, but now it's because this is flipped around, then polarity is reversed. And then what you do is interchange the letters. So then change letters. So that means that A becomes I and I becomes A. And when I say letters, I mean the letters of T1 and T4. That's the only thing that we're dealing with. Again, C, E, and G don't ever change. So change letters. T1 becomes T4 and T4 becomes T1. So using this as an example, if I have this motor set out the way it is, and I measure 12 volts here, and I measure 12 volts between A and G, then I know that this is this is I, and then T4 is A, because they're both 12 volts. Now, every now and then, you're going to measure something different than 18 or 12. And I say they're about, so 17.6 or 8 or something like that, or 18.2. Let's say one side is 18.1 and this side is 17.6. That's still good enough. And a little bit of practice will show you that. Same for the, around 12 volts. So if it's 11.5 and the other one's 11.8, you're in the ballpark. But if you measure, let's say 15 volts here, and I don't know, 15 volts here, or 15.2 or 14.5 or something, something's wrong, and it's in the process of something that you've done in previously. So you got to start from the beginning. So let's just write that down here. If none of the above applies, start from the beginning. Start from step 1. And that'll be in the previous video. Okay, so let's end it here. Now there's still another part to this, so I'll see you in the next video.